G'day guys, welcome back. We're going to try and make a small engine dyno, good for around about, I don't know, 10 to 15 horsepower, which should be more than enough for our little push bike motors. We're going to do it using a alternator. This is good for around about 120 amps, and if we remove the regulation, we should be able to get around about up to 100 volts out of this, and into a dummy load, that's around about 10 kilowatts, which is around about, I don't know, 14 horsepower maybe. I'll double check that. Anyway, so we're going to use this as the brake or as the load for the engine, and we're going to monitor how much current and voltage it makes, and that'll give us a rough estimate on output power in kilowatts minus the inefficiencies. So the total numbers aren't that important, it's more run-to-run comparisons. So anyway, we're going to use this thing here. Now this needs to spin between 10 and 15,000 RPM maximum. The reduction gears in our little engines are 1 to 4, so we need to increase the RPM from our engine or from the sprocket up to around about 10 to 15,000 RPM to make the best use of the alternator. So to do that, we're going to use a power steering pump. Not the pump itself, but just this larger pulley here. So this is around about 160 millimeters diameter, and this is around about 40 millimeters diameter, which makes 4 to 1 speed increase. And we're going to use this guy here. We're going to bolt that onto that, and this will be driven by the engine. It'll spin this up. This will be connected to this with a belt, and that should increase the RPM 4 to 1. So it should be more or less 1 to 1 engine RPM to alternator RPM. To adjust the load, what we're going to do is we're going to remove the regulator here, and we're going to control the rotor field strength directly with a variable power supply, and that'll adjust the load from 0 up to, I don't know, 15, 20 horsepower or so. We need to dump all this energy, so we're going to use a large resistor, either water cooled or air cooled, I'm not too sure yet, and that'll dump the energy as heat, and we'll monitor the voltage at the resistor so we know how many kilowatts or horsepower is being dumped. So that's the basic idea of it. First up, we need to split this open. I'm not sure how hard that's going to be. I think we might need a puller, but we'll see. And we will bypass this regulator here, and we'll just connect the rotor windings directly to these two pins here. And then we can start building up our sort of steel chassis to mount it all together. Alright, so I'll start with opening this. Looks like a couple of screws here holding the two halves together, and we're going to need to get this pulley off as well. Or maybe we're not. We'll try our luck just getting this these 4 screws off and hopefully separating the back half. That looks to be around about a 10 millimeter socket. I'll be right back. Oh, yep, it's coming. Yep, so this front's got to come off first. Oh, nice. What do you reckon, those screws are like a bearing carrier, or we can just push it out? Give it a little tap tap. Feels pretty solid. Yep, that was a bearing carrier, but we didn't need to remove it. So now we know. Alright, so there is a bearing, and that's what was holding it in. Just some light tapping, pulling out the shaft, got the rotor free. So that's done. Now we can get to these screws and remove the, geez, it's filthy in there. We can remove the regulator and modify that. The brushes in there, if you can see them, there's still heaps of life on those. So that's good. Let's try get this module out. Okay, so there it all is. This is the three-phase regulator, which goes from AC into DC out of this terminal here. We're going to keep that because we want DC. It's easier to measure rather than doing the math for AC. And this is the regulator here. So it'll monitor the voltage from the regulator here. Sorry, the diode pack. What is that? Anyway, and it'll try and maintain about 13.8, 14.4, around about there, volts out of this peg here. So what we're going to do is, we're going to try get to where these springs are, which you can see here. These are the brushes which run against the rotor commutator here, and that's what gives the current to the stator. And the more current that goes into this, the more voltage that comes out of this. So by this little module here, controlling the amount of current going in, it controls the voltage coming out of here. What we're going to do is we're going to change the current going into here to increase the load on the engine which is turning it. So to do that, we need to somehow get this out, and we want to connect both of these directly to these terminals here. One of them should already be going there. Yeah, we'll find out. Okay, so what we're going to do is we're going to solder two wires directly to these two terminals here, and I think we're also going to cut the electrical connection between the regulator, and the diode pack. That way this can't really influence anything that we don't want it to. Alright, I'll be back with a soldering iron. This is definitely one of those jobs where you expect it to take 10-15 minutes, but we're already maybe 2 hours into this. But at least we know for next time. So unless you're using this exact same alternator, chances are this is not how yours is going to look. But what we've done here, if you are using the same, we've removed the diode here. We've connected the two wires directly to the brushes. Now there are electronics still attached to the circuit for the brush current control. So what we're going to do is power it up with this bench power supply here, and just make sure that we can feed it up to 12 volts without this circuit influencing or affecting any of the electronics or any of the field current. So what we'll do, I've got this wire. Alright, so black stripe will be negative and red will be positive. Hopefully we get no current flow. Alright. Yep, I think we're pretty good here. 13 volts and no current. There is a slight increase as you increase the current, which suggests that there's capacitance in there. Which may affect our pulse width modulation, which we're eventually going to use to control the field current. But it's very minimal. I think we should be fine. Okay, I'll give this a bit of a degrease, put it all back together, and then this part of the thing is done. I just thought I'd show this little trick here. There's a tiny little hole at the back. You put a pin in there, and then you can push the brushes here in with like another pin and lock them in place, and that'll help getting the rotor back down in there. Otherwise, I think it's pretty much impossible. We'll just do a quick test to make sure the theory is all good before we go too much further. So I've got this earth strap, and this should be a resistor, but for proof of concept this will be fine. And we're going to spin up the alternator using our we'll spin it up using our impact driver. And as we increase the current, it should lock the rotor up or apply more torque, more force. So make sure we can spin it up now. Looks good. I was hoping to get a bit more done today than just this, but I mean, it's better than nothing. We know it works. It's all secured. There is a bit of friction. I think I might have bent the fan in there just a touch, but that'll self-clear once it's spinning up to 15,000 RPM. Alright, I'll head into town, grab some steel, and we'll get started on building the base plate, all these brackets and fixtures. And yep, I'll see you in the next video.